It's not a game, it's a rich thing.
Every black hole contains another universe. Equations predict, like part of a cosmic Russian doll, our universe may be perfectly nested inside a black hole that is itself part of a larger universe. In turn, all the black holes found so far in our universe, from the microscopic to the supermassive, may be ultimate doorways into alternate realities. According to a mind-bending new theory, a black hole is actually a tunnel between universes, a type of wormhole. The matter the black hole attracts doesn't collapse into a single point, as has been predicted, but rather gushes out a white hole at the other end of the black one, the theory goes. In a paper published in the journal Physics Letters B, Indiana University physicist Nikodem Poplawski presents new mathematical models of the spiraling motion of matter falling into a black hole. His equations suggest such wormholes are viable alternatives to the space-time singularities that Albert Einstein predicted to be at the centers of black holes. According to Einstein's equations for general relativity, singularities are created whenever matter in a given region gets too dense, as would happen at the ultra-dense heart of a black hole. Einstein's theory suggests singularities take up no space, are infinitely dense, and are infinitely hot, a concept supported by numerous lines of indirect evidence but still so outlandish that many scientists find it hard to accept. If Poplawski is correct, they may no longer have to. According to the new equations, the matter black holes absorb and seemingly destroy is actually expelled and becomes the building blocks for galaxies, stars, and planets in another reality. The notion of black holes as wormholes could explain certain mysteries in modern cosmology, Poplawski said. For example, the Big Bang theory says the universe started as a singularity. But scientists have no satisfying explanation for how such a singularity might have formed in the first place. If our universe was birthed by a white hole instead of a singularity, Poplawski said, it would solve this problem of black hole singularities and also the Big Bang singularity. Wormholes might also explain gamma-ray bursts, the second most powerful explosions in the universe after the Big Bang. Gamma-ray bursts occur at the fringes of the known universe. They appear to be associated with supernovae, or star explosions, in faraway galaxies, but their exact sources are a mystery. Poplawski proposes that the bursts may be discharges of matter from alternate universes. The matter, he says, might be escaping into our universe through supermassive black holes, wormholes, at the hearts of those galaxies, though it's not clear how that would be possible. A supermassive black hole sits inside the galaxy Centaurus A, as seen in a composite picture. Image courtesy NASA, CXC, CFA, R, Craft ETL, MPIFR ESO, Apex, A, YCTL, and ESO, WFI. It's kind of a crazy idea, but who knows, he said. There is at least one way to test Poplawski's theory. Some of our universe's black holes rotate. And if our universe was born inside a similarly revolving black hole, then our universe should have inherited the parent object's rotation. If future experiments revealed that our universe appears to rotate in a preferred direction, it would be indirect evidence supporting his wormhole theory, Poplawski said. The wormhole theory may also help explain why certain features of our universe deviate from what theory predicts, according to physicists. Based on the standard model of physics, after the Big Bang the curvature of the universe should have increased over time so that now, 13.7 billion years later, we should seem to be sitting on the surface of a closed, spherical universe. But observations show the universe appears flat in all directions. What's more, data on light from the very early universe show that everything just after the Big Bang was a fairly uniform temperature. That would mean that the farthest objects we see on opposite horizons of the universe were once close enough to interact and come to equilibrium, like molecules of gas in a sealed chamber. Again, observations don't match predictions, because the objects farthest from each other in the known universe are so far apart that the time it would take to travel between them at the speed of light exceeds the age of the universe. Inflation states that shortly after the universe was created, it experienced a rapid growth spur during which space itself expanded at faster than light speeds. The expansion stretched the universe from a size smaller than an atom to astronomical proportions in a fraction of a second. The universe therefore appears flat, because the sphere we're sitting on is extremely large from our viewpoint, just as the sphere of Earth seems flat to someone standing in a field. Inflation also explains how objects so far away from each other might have once been close enough to interact. But assuming inflation is real, astronomers have always been at pains to explain what caused it. That's where the new wormhole theory comes in. According to Poplawski, some theories of inflation say the event was caused by exotic matter, a theoretical substance that differs from normal matter, in part because it is repelled rather than attracted by gravity. Based on his equations, Poplawski thinks such exotic matter might have been created when some of the first massive stars collapsed and became wormholes. There may be some relationship between the exotic matter that forms wormholes and the exotic matter that triggered inflation, he said. The new model isn't the first to propose that other universes exist inside black holes. Damian Eason, a theoretical physicist at Arizona State University, has made the speculation in previous studies. What is new here is an actual wormhole solution in general relativity that acts as the passage from the exterior black hole to the new interior universe in our paper. We just speculated that such a solution could exist, but Poplawski has found an actual solution, said Eason, referring to Poplawski's equations, who is not involved in the new study. Nevertheless, the idea is still very speculative, Eason said in an email. Is the idea possible? Yes. Is the scenario likely? I have no idea, but it is certainly an interesting possibility. Future work in quantum gravity, the study of gravity at the subatomic level, could refine the equations and potentially support or disprove Poplawski's theory, Eason said. Overall, the wormhole theory is interesting, but not a breakthrough in explaining the origins of our universe, said Andreas Albrecht, a physicist at the University of California, Davis, who is also not involved in the new study. By saying our universe was created by a gush of matter from a parent universe, the theory simply shifts the original creation event into an alternate reality. In other words, it doesn't explain how the parent universe came to be or why it has the properties it has. Properties our universe presumably inherited. There are really some pressing problems we're trying to solve, and it's not clear that any of this is offering a way forward with that, he said. Still, Albrecht doesn't find the idea of universe bridging wormholes any stranger than the idea of black hole singularities. And he cautions against dismissing the new theory just because it sounds a little out there. Everything people ask in this business is pretty weird, he said. You can't say the less weird idea is going to win, because that's not the way it's been by any means.
Interesting.